So what we are going to cover today is about the compressed air system. Okay, we are not going to see the working of compressor, but we'll be seeing about the different air what is used on the ships and the SOLAS requirement for air bottle, safety devices on air bottle or a compressor. So I've just depicted here with a line diagram, and this line diagram shows that how this is being taken, the air is being used for different purpose on ship. So compressor, you can say, is the heart of the ship. And we have three, you talk about main engine, we talk about generator engine, anywhere. So air is important for requirement. So we have air bottle where the air is being stored. Okay, we also have an emergency air bottle. Okay, and so this is the rough idea and rough diagram. So we have two in number, the compressor is that is mandatory, but you will find mostly some three in numbers as well. Okay, so when we talk about main air compressor, so as I said earlier, it is the heart of the airline on board. The air compressor compresses air by means of reducing its volume so as to raise its pressure. So we want to raise its pressure, so we are reducing its volume. They can be of various types. When we talk about it, then it is centrifugal compressor, we have rotary vane compressor, rotary screw compressor, reciprocating air compressor, and then we also have most modern merchant vessels are employed with multi-stage reciprocating air compressor. They have intercoolers, and they also have aftercoolers with auto draining and unloading arrangement. So what is the function of an unloader and what is the function of a draining arrangement? So that we may not be covering it here today, but this may be also asked in a separate question, that what are different types of compressor used on board ship, and uh, uh, the type which is being mostly used. Now this is a separate thing that will be asked to you all together, that is intercooler, function of an intercooler. So when we talk about intercoolers, so it is generally arranged after every stage of main air compressor. Generally we have two stage air compressor to reduce the work done in compressing the air by successfully cooling it down between stages. So when we cool down, because generally when anything is compressed, the temperature rises. If you see the temperature curve, then it will rise when you compress in a confined volume. So the intercooler is generally form of copper tube bent in a U form. So I'll show you the diagram. The air passes through the tube and water circulates around them. See, for water cooled intercooler, for water type of air compressor, we have water type of intercooler. For air cooled, that we have air type of intercooler, air cooled intercoolers. Okay, so here you see there is air inlet and there are baffle plates, similarly like a heat exchanger. So there is nothing to explain, and you can see here a drain valve that is available. Same way is aftercooler also. We have aftercooler after the second stage, before making it go to the bottle. So an aftercooler is a heat exchanger used to cool compressed air after leaving the compressor. So when the air leaves the compressor, then the aftercooler cools the air again. So cooling reduces the air temperature and precipitates out water droplets. So whatever water droplets we have, that's the reason why on every watch or every 2-3 hours we need to drain the air bottle. There you also find in the draining place there's a corrosion symptoms. Aftercoolers incorporate a moisture separator for this purpose. Aftercooling reduces the volume of air, but this presents no power loss. So there is no power loss. Okay, because for the same in the same confined air bottle, you can store more volume of air. When you compress it, bring the temperature down. Okay, now what is the capacity? This can also be an independent thing. So two things we have discussed: what are different types of compressor that is being used on board and which is being widely used on board. What is the function of intercooler and aftercooler, that also we have seen. And then what is the capacity? This is all together that can be asked. So how do we measure the capacity of an air compressor? So when we talk about the capacity of main air compressor is expressed in terms of free air delivery, that is FAD. and is stated in cubic meters per hour. So it is meter cube per hour. Okay, if we define free air delivery, it is volume of air actually discharged by the compressor in 1 hour. Okay, from the unit only they are defining it. So volume of air that is actually discharged by the compressor in 1 hour, that would occupy if expanded down to atmospheric pressure and cooled to atmospheric temperature. Okay, now when we talk about SOLAS requirement, so for air compressor we have SOLAS requirement that a ship's main air compressor should be able to fill its reservoirs from 0 to maximum pressure 30 bar within 1 hour. So within 1 hour, so it must be able to fill the reservoir, that is air bottle, from 0 to maximum 30 bar within 1 hour. A ship may have 2 or 3 main air compressor, as I told you earlier, depending upon many factors such as each air compressor capacity, amount of volume of air needed for starting of the main engine, demand of air on that particular ship, etc. Okay, so when we talk about compressed air, though, so we have broadly in three category. We need air on board ship. Same air which is being stored by the air compressor in the air bottle, it is being used in three different forms. So that first one is the starting air, which is very important, so because of which the engine would not start. So that is in high pressure air that we say of 30 bar is mainly used for main engine starting. Okay, starting air line, you must see, that is very important. And by the way, if you have not watched the video of bumping clearance, okay, where I have covered this bumping clearance aspect in a previous thing, that is also very important, a separate, do watch it. And how we take bumping clearance, that is also being covered already. The air, then we have service air. When we talk about service air, so with the help of a reducer, this reducer valve, so this air which is at 30 bar stored in the because both the line for starting air, for main engine starting air line also, it is going in the same, from the same air bottle, and from service air and control air it is going with the same bottle. So how it is coming, because this amount of air is not required in the service purpose. What is required is 7 to 8 bar. So for what purpose we are using for service air, as starting air is being used for main engine starting, so service air is used for auxiliary engine, which may also go up to 11 bar, emergency generator, charging of fresh water and drinking water. Hydrophore, you see that hydrophore tank, when you see, is half filled with water and half filled with air, mostly it is 70%. Or likewise, blowing the foghorn, spring air for exhaust valves of main engine, dry washing of main engine turbocharger for use in sewage treatment plant for aerobic sewage breakdown in STP. You see, on the first stage only we are injecting the air. Soot blowing of boilers, pneumatic pumps for oil transfer, and many more applications such as service air for the use of cleaning, painting operation, chipping. We are also doing chipping of pneumatic tools such as grinder, chisels, etc. So for all these purposes we use this 7 to 8 bar air, which is used for all these purpose. Now third category is of control air. One more important branch of 7 to 8 bar compressed air. The control air is filtered branch of service air, which is made free of any moisture and oil carryover. So it is made free from any moisture or carryover. The control air is used for pneumatic controllers and is important for the operation of machinery on board ship. So it is important for the operation of machinery on board ship. So all those pneumatic equipment that you see, they require this control air because it is very sensitive. We cannot have an iota of moisture or oil to be passed. So control air is a very ultra filtered air, you can say. When we talk about main air reservoir, so each ship is equipped with two set of reservoir. They may be of vertical or horizontal type. So either the case may be. Air reservoirs are hydraulically pressure tested at 1.5 times its working pressure. So 1.5 times its working pressure we are testing it, the air reservoir. So as per SOLAS, what are the SOLAS requirement for this main air reservoir or the air bottle? That is a separate question, and that is very important. The total capacity of air reservoir must be efficient to give at least 12 consecutive 12 consecutive main engine start for reversible engine. So when we are talking about a reversible type of engine, then it has to have the capacity of air bottle must be such that it must be able to give 12 consecutive start, means subsequent starts, and at least 6 consecutive starts for non-reversible engines. For engines which are non-reversible, it has to be able to give 6 consecutive start without refilling of the reservoirs. There must be 2 identical main air receivers and 1 emergency air bottle for every vessel. So that must be 2 in number. 2 in number, 6 consecutive start for non-reversible, 12 consecutive start for reversible. And for air compressor, when we talked about that, in 1 hour it must be able to fill the complete bottle from 0 bar to 30 bar. Okay, so these are required. This is what the SOLAS has to say. Now this is the air receiver that you are seeing. So when this can be a separate thing and question that what are safety arrangements on air bottle or an airline system, and as well as what are mountings on an air bottle or air reservoir. So you see your manhole door for inspection, fusible plug, drain valve, circumferential steam, longitudinal stream. We have service air, visual air, relief valve, air to engine, pressure gauge, inlet from compressor. So that is also coming here. So we have manhole door. See, this is also very important thing. If you want me to cover, you can comment, then I'll be covering it. That why manhole doors are elliptical in shape. So it's not maybe asked, but yeah, that's a very important thing and one should know. Each air reservoir should be equipped with the following mountings. When we talk about fusible plug, so you see here fusible plug composition is bismuth 15%, tin 30%, lead 20%. The melting point would be approximately 220 degree Fahrenheit, and that when we talk about in degree Celsius, it is 104.4 degrees Celsius. Fitted at reservoir's bottom or on the reservoir at the ship side when a relief valve safety valve is not directly fitted on the reservoir. So when the relief valve safety valve is not fitted directly on the reservoir, that can be a line, and where then it is safety valve sometime is fitted. It is fitted to release the compressed air in the event of abnormally high compressed air temperature. So if abnormally inside the compressed air temperature rises, this fusible plug will fuse. Similar kind of thing you will find that, but the name is different and little property is different. The bursting disc that is on CO2 air bottles. I've also covered about the CO2 everything, you can watch. So when we talk about atmospheric relief valve, it is provided as overpressure protection and as a backup of fusible plug. So it is a backup of fusible plug. In case of engine room fire, when CO2 flooding is required, this valve is to be opened before evacuating the engine room. So this valve is to be opened before evacuating the engine room because it has fresh air, you can say, which is being stored. The air receiver relief valve opening could either open outside the engine room through the ship's funnel or inside the engine room itself. In case of the latter, CO2 bottle circulation for fighting a fire in the engine room is done accordingly, and the extra CO2 required is taken into consideration at the ship's design stage. So this is also a requirement, and which is very important requirement, that this valve has to be lifted, the air bottle has to be emptied before releasing the CO2 system in case of an engine room fire, and this also is taken into consideration when calculating the amount of CO2 that I have already explained in the CO2 video. Spring loaded safety valve, when we talk about, that is setting pressure would be 32 bar for a 30 bar working pressure with equal to or greater than 10% rise in accumulation of pressure may be fitted directly or with extension. Okay, there are compensation ring when a hole is cut, as I was talking about why manhole door is elliptical in shape, not circular or square or rectangular. So there is the reason being is that I'll explain you here only, that whenever there is a cut in a pressure vessel, so what is that, the area has to be minimum. So the area obtained in a spherical shape or elliptical shape, that is minimum as compared to the circular. So area for the same amount of radius than we're talking about, the area obtained in a circular shape, that would be minimum as compared to a spherical shape. So and to remove the stress concentration, because at corners we need a round and smooth finish. So what happens whenever there is a corner or edging, then what happens, the stress concentration at the corner and at the edge increases. which what happens is that this will increase the stress concentration in the corner. So the use of square or rectangular shape is already omitted out. Okay, so that's why we have a compensation ring. So this is also a mounting sort of say, because already there is a material loss. So to avoid that and give strength to, because it's a pressure vessel, so we need an extra ring which is put inside the inside. So that is known as compensation ring. When a hole is cut or machined into a pressure vessel, higher stresses will be subject to the material around the hole, and to reduce this, compensation rings are fitted. It is a flange on which a valve or fitting is usually mounted. A compensation ring provides for structural integrity in the air pressure vessel. Okay, manual drain valve or automatic drain valve, these are self-explanatory. We have pressure gauges. This is the modern pressure gauge. This is also a very important term. What are different types of pressure gauges? We have access doors as well, which is manhole door. You see here now, this is the relief valve that we are talking about. Okay, and we have filling air valve. This is the filling air valve. From this line is coming from the air compressor. Now we have main air starting valve. Main and starting valve for main engine, this is going on. We have this service air outlet. Okay, this is service air outlet. This is the main air bottle. We have pressure gauges. Okay, we have this inspection manhole door that we are talking about. Okay, and it is elliptical in shape, and you can see here it is a compensation ring that we were talking about. Now main starting valve, auxiliary starting air valve, fitting valve, service air or visual air valve. Large cylindrical air bottle usually have no longitudinal welding seam. The longitudinal and circumferential seam is machine welded with full penetration weld. The welding details are governed by pressure of air that is to be stored in the conjunction with classification society regulation. All welded air receivers have to be stress relieved or annealed at a temperature of about 600 degrees Celsius, and the welding is to be radiographed for safety purposes. Receivers are subjected to statutory survey and inspection. Periodically, hydraulic tested at 1.5 times the working pressure is to be applied every 10 years for large receiver. Okay, so this is also a requirement that about the pressure testing that we have already discussed. Safety devices on air bottle, when we talk about fusible plug, pressure relief valve, atmospheric relief valve, low pressure alarm, automatic or remote control, moisture drain valve. Okay, so today you see here that was a vertical sort of thing. In this image that you saw, it is in vertical position. So this was also a SOLAS requirement that it can be in vertical or it can be in horizontal position. This is the diagram for another ship where you find the air bottle is horizontally placed. So today we saw about what are different types of compressor, which type of compressor is broadly used on ship, what is the SOLAS requirement for air compressor to be as per quantity, as per filling capacity. Then we saw free air delivery, what is it, what are safety devices on air compressor, and then we saw about main air reservoir, what are different type positions, and what are SOLAS requirement, what are safety devices that are fitted on main reservoir, and why there is a compensation ring, why manhole door is elliptical in shape. Now all those things we covered, and what is the function of a fusible plug, the fusing temperature, what is there, and all those things in detail. Thank you so much.